Hello, my name is Eva Revear, and today I'm going to go over deploying a recommendation system with MLOps. So first, a little bit of background about me. I'm currently a data engineer at a mid-sized insurance startup focusing on data platforms as well as data modeling and architecture and analytics reporting. I'm still pretty early in the process of learning data science and machine learning, so I'm focusing on expanding my engineering skills into ML technologies. So the goal of this project was really to build a general understanding of the tools and processes that we use to productionize machine learning models. We explored both serving and scaling a prediction service, as well as creating a pipeline for continuous training. And we really focused on understanding the MLOps lifecycle, as well as maturity levels, and experimented with tools like TensorFlow for the different steps. So at a high level, we basically built a recommender system and deployed it. Our data set was the UCSD book graph, which is a Goodreads data set with about 2 million books and 100 million ratings and read or unread statuses from bookshelves. And after doing a little bit of EDA, we only ended up using about 40 million ratings for the final training. Most ratings are on only about a few thousand books, so a handful of the whole collection, and using all of the data ended up being really noisy. So we just used a subset. So this is the overall architecture of the system, kind of from how we built out the model locally, first in Jupyter, and deployed the prediction service as a Streamlit application using Cloud Build for the CI/CD and using a training pipeline. And the next few slides will kind of go over each piece in a little more detail. So first, we're going to go over the model development and deployment. So a little bit about the model. We built a two-tower retrieval recommendation model that uses the TensorFlow recommenders package. And this allows us to use a hybrid content and collaborative filtering system. So a system based both on the similarities between objects, but also on what similar users have liked. So the model learns embeddings by capturing semantic similarities between users and items and clustering those similar things together. And typically this would allow you to make predictions for a specific user based on what they've liked before. But since we wanted a very simple UI, we ended up using a cosine similarity model based only on the learned book embeddings. So for the actual application, after model training, we simply pull out the learned book embeddings and send them to a cosine similarity function when the user inputs a book title. And since the prediction service is using the learned embeddings instead of model predictions, we use a custom serving signature to take in the index of a book and return its embeddings instead of taking in a user ID and returning a list of books as would be typical. So the model training pipeline was built in TFX and uses the Kubeflow DAG runner. We deploy and run it in Vertex AI pipelines using a custom Docker image that contains the required TFX recommenders package and a few other things. And the pipeline pushes the train model to a GCP cloud storage bucket, which we're sort of using as a registry. And once the trained model is available, we leverage TensorFlow serving and GKE to create an API that will allow us to access predictions. And the TensorFlow serving is deployed to GKE via a Docker image. And we set all of this up to run through configs, which we can load and run in GCP through the console. And now we'll take a little bit closer look at the application side of things. So we create another Kubernetes cluster and set of configs to deploy the UI as a Streamlit app. And that allows us to interact with that prediction service. And we use Cloud Build to deploy the whole thing. So the app takes in the name of a book and turns that name into an index number, hits the prediction service, and with that value, uses that value to pull in the learned embeddings for the book and then compares it to the rest of the model's learned book embeddings, which are stored in a pickle file, also in cloud storage. And typically you wouldn't need to serve embeddings this way when you have them all stored, but we wanted to do the TensorFlow serving piece for the sake of the exercise. But then as you can see here, we return a graph and graph a list of books similar to the ones input by the user. So here the user is inputting the book Sharp Objects, and we get some pretty decent recommendations, some other kind of female-led thrillers, and a couple of books by the same author. And one more example, here we're putting in the Vampire Academy book, and it's basically going to pull for us the rest of the series, which obviously if you like the first one, you'd probably like the rest of the series. So yeah, if you want to see how all of that works together, you can check that out on GitHub, or feel free to reach out to me on LinkedIn. I'm always happy to chat about this. And thanks to the KaggleX team for this fantastic opportunity, and for my mentor for the guidance and feedback.